So, good afternoon to you all. Welcome to the final parallel session of today. This session is on the green vehicles, modeling and testing of electric vehicles. I guess if you were expecting to be in a safety session, now's the time to go back to the lobby and press the other button on the program. For your information, my name is Simon Edwards. I'm a Global Director of Technology at Ricardo. I'm also the Vice Chair of AirTrack, one of the Vice Chairs representing the research providers. So it's been my pleasure to see what's been going on these past 2 days and also to moderate this last session with you. I think most of you know by now the procedure we have for this meeting. 4 projects to present, and we'll then follow that by a question and answer session. Hopefully that will go smoothly. But first of all, which I'm sure will go smoothly, I'll hand the floor to Maurizio, who I'm sure all of you know already from DGRTD, to give us a brief introduction on the topic in a little bit more detail before we move to the presentations. Maurizio, I think the floor is yours.
Thanks, Simon. Good afternoon, ladies and gentlemen, and thank you for attending this modeling and testing session. I am Maurizio Maggiore from Unit D2 of DG Research. I'm in charge of defining Green Vehicle Initiative topics like this one and of feeding research results into EU policies, particularly now that the Green Deal is giving high priority to zero climate and health affecting pollution transport. In fact, these are issues that we try to cover every 2 or 3 years in the work programs to facilitate the transition to zero-emission vehicles and build in as short a time as possible the volume and capability of modeling and testing that has been available for years in the automotive and combustion engine world, while at the same time taking the opportunity to fully exploit the new IT tools and concepts which are emerging and transforming the CAE world. Vehicle and components design is the first area, of course, which is already well covered, but can be further improved in light of the needs, of the specific needs of zero-emission vehicles. For aspects like crash, we have the additional, let's say, demands, for instance, of the battery and mechanical component design. But it's not only the basic design of the vehicle that we want to address. CAE tools are needed to assist the concurrent evolution towards a digital resource efficient and circular automotive world, while reducing costs and increasing component integration into, let's say, all the levels. We have to consider that we will be more and more covering not only the vehicle, but also the levels up in the chain, like the charging. And look at advanced manufacturing. Comes to mind the 3D printing and, for instance, the huge casting, which has been announced recently by Tesla. All these things will be evolving for sure in the future and needs support from CAD and CAE tools. We need to address the thermal aspects and the thermal management in general of vehicle design, and the impact that these thermal issues have on vehicle range, battery fast charging, keeping the user comfortable when heating or cooling, but at the same time saving energy by having thermal insulation and improved devices. All this needs also support in design. Advanced design tools will allow to reduce, on one end, the development time, which is, let's say, important in competitiveness of the industry, and cost, which is even more important. And on the other hand, will be an enabler to achieve better performance and safety by allowing to do simulation at many more, let's say, different levels, many more different configurations to be compared, and therefore helping in getting better results, better final results. And a particularly important approach is to concentrate on the early design, where most of the final results in the end are committed with the very basic choices, with a relatively small part of the total development effort. So It's an important approach in things like this, which are evolving very fast. Battery modeling is, of course, a paramount in these vehicles. It would be also for fuel cells, but this is not in our domain. And we need to tackle that at all levels. We need to look at the cell development, integration into batteries, aging, dismantling and recycling, safety, all these things. And of course, battery management systems, which also need and use models internally and need to be optimized for the huge impact they have on battery life, range, and safety. And finally, design is not the only aspect that's being improved by moving it to the virtual world. Testing through simulation and all X-in-the-loop methodologies can give a large contribution to cutting times and cost. Since building prototype, hardware components of different configurations to be compared, for instance, is a costly and time-consuming endeavor, and this can be reduced by this, up to the point of being able to do safety analysis, for instance, in a very exhaustive way in a virtual world. So let's now what this project and the session have achieved in these domains.
Maurizio, thank you. Very true words, very close to my heart, so I really appreciate that you've been able to say those, and thank you for that contribution. So as Maurizio says, we'll move on to the speakers now, but before we do, just a reminder, you all know the procedures by now, but questions, if you've got any, please write them in the chat box, which is just on the left of your screen. When you write the question, it would also be helpful, especially for me, to tell me which project you're actually asking the question about, so that we can identify those and make the discussion move more fluidly going forwards. But anyway, to the first speaker now. This is a presentation on the Quiet project. Thank you, Jens, for that overview on the Hi-Fi Elements project, and thank you then to all the speakers. I guess now's the time to turn your cameras on and join me for the question and answer session. We've still got about 15 minutes or so to go, so we've got time for a few minutes for each of the projects. Maurizio, if you wish to join us as well, you're more than welcome to come on back online. What I'll try and do is I'll just pick up on the questions that have been put in the chat area and step through them in terms of each of the individual projects. If people have still got questions on the Hi-Fi Elements project, please add them and we'll bring them in towards the end. But maybe then if I can start for everybody with the Quiet project. So Dragan, from your side, we clearly had three projects that knew each other well, and then we had your Quiet project. But let's ask some pertinent questions on your project first of all. And I think Maurizio actually posed one of them, which we should look at, which is a little bit in relation to this idea about lightweighting and thermal insulation. Is that not a compare and contrast? Can you actually achieve the two together? And if you did achieve something with lightweighting, then what did you achieve, especially under not so extreme conditions? So under some of the more conditions, what did lightweighting bring for you, Dragan?
So hopefully you can hear me. Connection is good, or?
Yeah.
Okay. Thank you very much. So as I presented in extreme cold driving conditions at minus 10 degrees, we achieved driving range extension at about 27%. If I calculate how many from this 27% we win to lightweight components, then it's approximately 2 to 2.7, independent on the driving cycle, of course. Regarding also, that means in general, without lightweight components, we can achieve extension of the driving range at around 25%. Related to the second question was related to, sorry,
Yeah, say less extreme temperature. I mean, some people will have a benefit from -10, but a lot of people probably will have a benefit for 10 or 0 or something like that.
Yes, I'm so sorry for this. So at the moment, we have only simulation results, which shows also that, let's say, at around 0 degrees, we can also extend the range for around 70 to 20%. Of course, again, independent on driving cycle. I'm talking here about WLTC driving cycle, but this is, Maurizio, something that we will finally test together at GRC, Joint Research Center. They are results that we have at the moment based on the simulation model.
Okay.
Thank you for that, Dragan. There was one other question for you, which I think we can just squeeze in here, which was related to the preheating of the batteries. Did you do anything of that, and what did it bring, if you did?
So, of course, if I understood the question right, the question was if we also include the preheating of the passenger compartment. No, into the project, we are not dealing with preheating. Why? This is then not a variable comparison between, let's say, referent vehicle and quiet vehicle. But in any way, we are dealing also with heating and cooling of the battery. We have also in our system or HVAC system, we integrated PCM materials, which can help us to cool down battery or heat up battery if necessary. And of course, especially in hot driving conditions, if we see that the battery temperature is too high, with our system, we can cool down the battery. And also in cold conditions, we can heat the battery if needed. We include this.
Thank you for that. I think that's covered that quite in detail. You can also see that we're getting one or other question also on the quiet project inside of the chat. Given the time and the delays that we've had, we'll move on. But what I would say is many of the projects have a booth in the lobby, so you can go and carry on the conversations there perhaps, or you have the direct contact with Dragan, etc. from the other presentations. So to be fair to all, let's move on and let's move to yourself then, Horst, on the Obelix project, if we can. And I noticed you got quite a few questions that all mentioned the word scaling. It was about whether your models could scale to go to other types of vehicles, or whether you could scale it for different types of inverters, different inverter sizes and anything. Can you tell us more about the scaling capabilities from what you've generated, please?
Mm-hmm. I think the scaling question here was, if you look at the question, for instance, for the motor, if we start with the e-motor, there was this design tool actually for the e-motor, where we where you can insert 3 main factors, which is speed, which is the maximum torque, which is the nominal torque, and out of that you get a complete simulation model. It's not the highest accuracy that you can get, so you do not have a 3D simulation behind it, but rather a simplified one, so that but it includes everything: electromagnetic, thermal, mechanic, and aging effects. And with that, you can create within a few minutes actually a complete new design of an e-motor, which you can play with and then further adapt. The scaling there, I understood, is, okay, can you do a small engine with 20 kilowatts and a very big one with 200 kilowatts? Yes, you can do it. And the scaling was meant there actually. And if you then want to go into further detailed simulation, you can do this as well. Yeah, so in this regard. For the, there was another question here I can read for the inverter scaling. This was the testing, actually, I understood. That means here we have inverter testing possibilities, actually, that allows some to test the inverter without having the real e-motor, the battery, available. And the inverter testing is a power hill that has a very high power, which you can test, so up to 1000 volts and 2000 amperes, so 320 kilowatts. And if you need more, you can place them in parallel. Actually, you can also downscale, of course, into this direction. I think this scalability was meant there. Maybe, I don't know, if you read anything out there additionally, just let me know, please.
Excellent, Horst. Thank you. I think, yes, you addressed the point about scalability in many different ways. One thing that you did scale very well was the amount of effort required to get through to the end of your activities. You gave some very impressive factors for the effort reduction. How did that come about, apart from just the scaling effect? What else gave you all those efficiency improvements?
Mm-hmm. Okay, yeah, there are two factors actually which you asked and which were mentioned. So the efficiency of the powertrain, actually, there are different factors, as you can read. There's not one that is above everything. Maybe the heat pump, using the heat pump for heating instead of the electric heating is one of the biggest one for the efficiency improvement. It's a little bit more than the rest, but it's not outstanding in this case. So there are others like component sizing, using new components for e-motors, inverters, using silicon carbide instead of silicon actually. Then auxiliary power management, controller management. There's also regenerative braking. If you have very good blending strategies, for instance, these are effects for the efficiency. On the other hand side, if you look at the efforts, I think the numbers that we have are very similar that Jens also told us. This goes into simulation and into testing. There, I think the key factor is automate the entire the work, more or less. That means creation of your models needs to be automized. Doing measurements and creating models or parameterize the models out of the data needs to be automized. The testing needs to be automated. Also, for instance, this back-to-back testing, as I have mentioned, or this inverter testing. So there are a lot of automation steps which you can apply in different stages. Of course, we have not improved the entire development process as a whole, but put out use cases. You saw 17 use cases. In every use case, we made this improvement, and this is quite, I think, impressive what has been done there, but it doesn't cover the entire development process. I think that's clear.
Thank you. So we've clearly done a lot, but we've got a bit more space to go as well, and I'm sure there'll be more coming from Jens in a moment. But Horst, thank you. Let's move on to Philippe, if we can, briefly. You mentioned you were concentrating on the battery side of things, and one or two of the questions that came up, you did clearly crash simulations in your vehicle with the battery pack involved, but did you do any other abuse testing of the battery itself or evaluation of the abuse test for the battery?
We don't make a battery crash at the battery pack level. What we did is to make the test at module level, at cluster level, at cell level. That means at lower scale level, and we were able so to predict the propagation by test, assemble different modules, propagations, cluster to cluster, modules to modules. So we don't go up to the full battery pack. We do it only by simulation. Otherwise, yes, sorry, maybe other questions.
So yes, there was a couple of other questions for you, yeah. And one of them was really, how did you get such good low results? If you have a look at that, what other innovations were there inside of the system that allowed you to get down to those very low effective results? I think it was over the WLTP or something.
Yeah. WLTP. Yes, I think that the first factor is the vehicle weight, simply. Yeah? but you know it is a main driver. So only to consider this point, because you can have everything efficient, but if your vehicle is heavy, you will have higher consumption. So it was a key point. Otherwise, you are very four-wheel drives, which also is a driver for energy savings, and optimization of the engine and things like that. But the key points, if you have to quote, I'm sure the key points is because with the structure of the vehicle, you manage to have a electric vehicle at low weight finally. So you save energy. It is a key point, and then you optimize all the system which can be done.
So, and get it the right size to begin with, and then you can push the optimization further.
It is a point.
Final question that came up in relation to your presentation, which moves that topic on even further. What about the recycling? Can you make any comments about the recycling percentages from your new battery pack, etc.?
Yes. So the point was to make an assessment of the battery recycling level. It is something a little bit tricky because regulation is moving. Today, regulation was at cell level, so it will be at module or at pack level. So it is something which is moving a lot. So what we observe in the project, demo-based project, at cell level, the recycling process efficiency was about 61%. 61%. So it was higher than the today regulation. The regulation, I think, will be pushed up because you have to know for IC, internal combustion engine vehicles, you must have a recycling efficiency of 95%. So we are not still at this level. What we highlight also was the point that depending on the pack disassembly method, dismantling method, you can have also different recovery rates at module or at pack level, depending if you are able to dissociate the different parts or not, because you have some metals which melt together, which can be difficult to separate when it is melted together. So the key point to treat is dismantling to assess, to have a good assessment of the recyclability of the battery. And it is important because we will work today. The recycling, we'll see the efficiency of the recycling after the lifetime of the battery, and it will be important. It is important to know today what is the status on the battery and feed.
Thank you, Philip. You've given us a good baseline, I guess, going forward with other projects.
Yeah.
Let's move on to the final project. We're getting close to time, so maybe Jens, just one question. Apologies, and about a minute's answer. In the meantime, I guess others could answer some of the other questions via the chat, whether that's for Dragan or for yourself, Philippe. But Jens, you saw the question there, I think, about what about other components? What about other types of vehicle architectures? How do you address those, or how will you address those going forwards?
Okay. What you can see from what I've presented already, we have, let's say, 4 different vehicle architectures for the BEV. So that's what is being implemented already. We have used something which is called the 150% architecture, which is basically, has an overwhelming architecture above it, which of course is not really technically relevant, but then you subtract basically what you don't need for the specific architecture. So definitely, I mean, Hi-Fi Elements, the results that we have made public, you could extend this, of course, to something like hybrid vehicles, fuel cell vehicles, and that would be actually what should be done, because there is a standard, and it would definitely help just to understand and assess the multitude or the complexity of these different components. If you add this, I mean, it would just have to be done, and people should evaluate this. This would be additional work. It's not really a challenge. It's just another busy work that one has to do, and people should think of, in order to be able to do lots of simulations, how to integrate all these different kinds of, let's say, different hybrid architectures into this overall 150% approach that we have done. So this is, I mean, that'd be exciting to do it, definitely.
Much appreciated, and I'm looking forward to how we use that standardization approach or standardized approach in some of the forthcoming projects as part of the Towards Zero activities
Yes,
as well.
exactly. That's what I would like to hope to see also.
That's good. So we've got 30 seconds left. So I'd like to literally thank all the speakers, the technical support as well. Verena, thank you for your persistence with all of this. Before you go back to the lobby, remember that most of these projects have a booth, so have a look at that as well. You can hear a summary of this session and of the other session immediately in the lobby before we move back to the closing session. So thank you to all of you for your attendance. I look forward to meeting you again sometime via some other media in the new year, I guess. Thank you. Goodbye.